Okay, so we're doing applications of what? Trig, right? Applications of trigonometry in 3 dimensions. So it says, using trigonometry to solve problems in 3 dimensions involves visualizing and drawing triangles. That can be kind of hard. Okay, especially from a description, that's the really hard part of what are they actually talking about. Then using trigonometric ratios, once we get the triangle drawn, how would you describe that triangle in there? Yeah, what is it? Like, I mean, if I couldn't see that picture and you wanted me to draw that, how would you tell me to draw that? You'd say, draw what kind of pyramid? A square-based pyramid, and then okay, how's the right angle triangle made? What's it made with? Let's do some math words. What's this thing? That's the height or altitude of the triangle. So from the middle of the bottom up to the point is the height or the altitude of the triangle. So that's one side of the right angle, the height of the triangle. What's this side? Is it? You can look down at your page too. What is that? What goes from here to here of a square? What's that called? Really? It's a diagonal. You know that word. A diagonal from one corner to a corner that's not next to it. Okay, so it's half the diagonal and the height makes the right angle triangle. So explaining things, you know, if they had said that to me in a problem, draw a square-based pyramid and form the triangle, you know, and they use those words in a problem, you'd be like, what? What does that mean? So you need to know the words. Okay. Relating answers from 2-dimensional diagrams back into the 3-dimensional object. Okay, so let's look at this one. This is a real common one. A vertical mast, what's that? Yeah? Yeah. Like, you know, the mast of a ship, right? So a pole is supported at the top by 2 cables reaching from 2 points A and B. So these are like staked into the ground, and that's the tower, and the cables are helping to stabilize it, right? You can't just put a gigantic tower in and have it stay up in the air and not wave around. So they attach cables to them to stay up, right? You've seen it a million times with power poles. There's one right in front of my house, and the cables come off to the side down to the ground. Note that when you're driving home today. The cable reaching from point A is 36 meters, and it's at an angle of 48 to the horizontal. Is that so far so good? And point B is 24 meters from the base of the tower. Find the height of the mast. Okay, so I can see 2 triangles there. Usually in a 3D picture, even though they're really easy to see, I'm just going to draw them separately, okay? So I'm going to put the mast and A and 36. This is the mast, yeah? And then I'm going to draw the other triangle, because when they're written like this, they're kind of swirly. 24 and B and the mast. Okay, so which one of these 2 triangles can I use? Oh, 48, sorry. Okay. Which one of these can I use to figure out the height of the mast? A, the one with A, yeah? Shall we name this M? Because it's the mast. Okay, so I'm going to go in that triangle. I know this angle. I have the hypotenuse. I'm looking for the mast. X? Sine. Okay. So A sine 48 equals x over 36. I don't have my calculator out. Can you just do that? Yeah, it says, find the height of the mast, correct to 3 decimal places.
26.75.
Altogether? 26.753. Is that it? It's the opposite, so I'm going to do, with my big calculator, sine 48. And then I'm going to times by 36. And that looks right, 26.753. Okay. And then it says, find the angle to the horizontal of the cable reaching from point B to 2 decimal places. So that's this thing here, yeah? That? We know what the mast is, don't we? 26.753. We know that. So now we have a side and an angle. So what are you going to use there? Tan theta equals, and what's tan? TOA? Tan theta equals TOA, so 26.753, sorry, it's right above me, over 24. Somebody want to ask a question right now? Here's the angle I'm looking for that the B makes with the horizontal, and this is opposite over adjacent.
So for A you found the mast, and for B you can use that answer to...
Couldn't have said it better. Beautiful. Okay, that's perfect. Okay, so tan inverse of .1? 48.10? I don't know, I guess that they want 2 decimal places. So theta equals 48.10 degrees. Okay, are you on your way? Go for it.